you can see the imputation has been done, right? That the same way you have to treat. So I am just treating each and every value. You have to repeat it, right? For saving the time, I am giving. I am actually treating each and every one. I don't know how many NAs are there, so that's why I am treating. You can just change that name here A3. If you have any confusion, you can interrupt in between. Right? So I have treated these four values, and then I have to see the data. Data is here. Yeah, A1, A2, A3, A4, A5, C1, C2, C3, C4, C5. So I am just going to treat this as well. So just copy from here and paste. So just make it C1, C2, C3, C4, C5, and here again C1, C2, C3, C4, C5. Right? So I have treated C1 as well, then other data, because number of the NA values are there. If you can just see the data, so we can't actually go and identify every time. You can just treat each and everything for saving the time. It's not a problem at all. So now E1, E2, E3, E4, E5, then N1, N2, N3, N5, and then O. So just quickly I am doing. So C1, then we have E. So from here, I'm just writing E1, E2, E3, E4, E5. And here also, I'm writing E1, E2, E3, E4, E5. Then we have N1, N2, N3, N4, N5. N1, N2, N3, N4, N5, N1, N2, N3, N4, N5. Then you have to run it again. And now last, you have O1, O2, O3, O4, O5. So O1, O2, O3, O4, O5, O1, O2, O3, O4, O5. Right. So now you can check the data again. So view data. So you can okay. So here mean has been written. Okay, so that means some silly mistake I have done over here. So one minute, just. So I think it is not in quote. No, something. Actually, mean has already been written. That's why this problem is happening. To run from here. Fine. Right, if you can see that all NA values has been imputed, if you can just see, there is no NA value right now. Okay. Education and age and gender has some NA values, so I'm not treating it because that are not required for the factor analysis. So other values has been treated. Now what you have to do, you have to actually eliminate some variables. If you can just see, row names are not required at all. I will eliminate this variable because this is not required for the factor analysis. I will eliminate gender, education, and age. So just counting numbers, one, one, you have to remove one, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Then 27, 28, and 29. So 1, 27, 28, and 29 you have to remove from this data, right? So how to remove? So just to please see carefully how to remove the data. So for removing, we use slicers. So I am assuming the basic data analysis, the basic data manipulation in the RStudio you all should know, right? Because we can't take in a 2 hours everything. So for that, you have to use data and square bracket for reading the data. So here I'm just telling you how to do it. It is actually row, comma, column. Row, comma, column, right? So we have to remove some column over here. So row हमें remove नहीं करनी. So that's why we will actually not take this uh, row. We will take the column. So which column we want actually? So see, we want the column number 1, then column number 27, then column number 28, then column number 29, right? And here just you have to put a minus over here. Minus means from the data you are removing these 1, 2, 3, 4, 5 variables, and you again just save these variable in some object. So I have taken the same object. Maybe I can take data 1 here, right? So that our data should not vanishes. Okay, and then you can just check your data 1. Okay, so first column has gone, and remaining that gender and education, that column has also gone, right? Now you have these many variables over here. Okay. So now I'm just going for the factor analysis. So before the factor analysis, you actually you can't do factor analysis directly. So first of all, you have to see some of the tests, right? So the tests are, 1 minute. You can interrupt in between if anything is going to the out of box. Just a minute. Okay, fine. Sorry, some document was there. I have to say. Yeah. Okay. So I'm just going to do some test. So first of all, you have collected this data, but we don't know whether this data is perfect for the analysis or not, right? So what do you mean by perfect here? Actually, perfect means whether it is adequate in nature or not. Should we go for the analysis or not, right? We have to actually see this kind of the things, right? You can just take, this is a very good library that is called core plot. Core plot is a very good library. You can just install it. Yes. So I am just taking this core plot library. Core plot, right? So for correlation, you have to just, I'm just taking the correlation first of all for this data. So correlation, so for the correlation, we have that function for the correlation that is called core, right? This is the statistical function core, and then you have to provide data one, which is our new data, right? And then we have to see what is there in the correlation. it is still running. Just we have to wait. Yeah, this is the correlation. If you can just see, let me just show you. This is the result of the correlation, which is not very. You can't actually see clearly over here. But why we do correlation? Actually, correlation we do to see whether our data has dependency or interdependency, right? So I think you should know what is the dependency and what is the interdependency. Interdependency means within independent variable, if few variables are highly correlated, then indirectly the means of that existing over there, right? What is the multicollinearity? So I'm just taking again that example. So the example I had taken one dependent variable and other independent variable. So multicollinearity means suppose two variables are giving same information to the dependent variable, right? So it is always advisable to remove one variable because we are getting the same information from both of the variable, right? So multicollinearity should be avoided from the data. So that's why we check the correlation. So in the correlation, you will be getting that 1 minute. You will be getting the correct. I'm just opening again it. And then actually, if you can see, it is very difficult to see in this data because actually I have zoom in this whole process. So that's why it is very difficult. So I'm just trying to visualize. So core plot is the library. I have just so core now here. So I'm just writing in the so core plot. You have to take core plot and then correlation that जो correlation हमने निकाला है so that correlation you have to take this is here, right? And then you have to run it. You can see this is the core plot, right? So what is the beauty of this core plot? So first of all, that dark blue color. So dark blue color is indicating that highest correlations. It is very common. A1 and A1 would be having 100% correlation because these are the same variable. A1 and A2, just we can see from here. Let me just show you correlation value for the A1 and A2. How much? So A1 and A2 is a negative 0.3369 and A3 and A2 is a 0.48, right? So A3 and A2, you can just see here A3 and A2, this थोड़ा सा dark है. So if it is little dark, that means some correlation is present. So 0.4 means it is correlation is there. That's why this blue color is little intense, right? And A1 and A2, if you can see, this brown color is little high. So what does it mean? It means if brown color is there, that correlation is there, but negative correlation is there. If it's dark blue is there, that means correlation is there, but positive correlation is there. You can see this one is the darkest value. So it is E4 and E1. No, yes, E2. E1 and E2. Let us see E1 and E2, how much correlation is there. So this is E1 and E2, 0.4643. E1 and E2. Am I right? E1, no, E2 and E3. E2 and E3. You can see 0.51, right? So little high. So 0.51 means that's why this is negative and darkest value. So how to see? You can't visualize here. You can see the value over here and you can visualize whether two variables are highly correlated or not, right? So that's why this chord plot is very, very important. So you can actually always use whenever you are going for the factor analysis. That is the chord plot. So after that, because how to actually identify whether the correlation is that multicollinearity is there or not. If the correlation is very intense, right? Intense means if the correlation, let's say, zero point 0.9 or above, 90% or above. So we consider, yes, there is a correlation, you have to remove one variable. And if it is not there, you can take all the variable as it is, right? So the question is it you have to take no correlation at all, or correlation is there, is it that is better or not? No. So the correlation should not be zero between the variable and should not be very high. So what is the exact way that correlation is good or not? So if you can see number of the blank spot in the middle, that you have to test. So this is the correlation, and the second test before the factor analysis is called KMO. So this is Kaiser. You can just see the spelling Kaiser Myon Alkin test, right? I just forgot that name. Kaiser Myon Alkin test, right? So that we do. So let us see KMO, how much KMO is there, right? So the thumb of rule is, if the KMO value for individual and group is 0.6 or greater, the factors are nature, right? So you have to see adequate, there is spelling, you can check adequate is. So for the factor adequacy, you have to just write KMO. Then you have to give data. Okay, function KMO is not there because we have to download the library for that also. The library for the KMO test is Psych. So I have this library with me. If you don't have, you can download simply from here. You can just go to the tools, install package, and then just write Psych, right? And you can install it from here. Okay. So then you can run the KMO. So please see the overall MSA measure of factor adequacy is 0.85. You can see the value here. I'm just a little bit. Yeah. And individual factor is also greater than 0.6. So that means our factors are adequate in nature. We can go ahead with the analysis, right? This is the first confirmation which we got from the KMO that our data is adequate in nature. What if our data is not adequate? Suppose one individual factor is giving 0.4, right? So what you have to do, that individual data is not adequate in nature, so you have to remove from the data simply, right? So since our each and every data point has value greater than 0.6, that's why we have to go ahead, right? So this is about the KMO. Then second test we do, that is called Bartlett's test of sphericity. Bartlett test of sphericity, right? So we do Bartlett test of sphericity. So why Bartlett test is important? Because in the Bartlett test, our assumption is there is no correlation between, so this is the null and is alternate hypothesis, sphericity. So here we take null hypothesis. So our null is there is correlation between variable, and our alternate is there is no correlation, right? So ultimate our aim is we have to reject the null. So if the value is less than 0.05, you have to actually reject the null. So how to test it? So BART test So for this we write core test, CORTEST, core test Bartlett, right? This one. And here you have to provide the data. Not data, is data one actually. Sorry. Okay, so it is, I think, core and then data one. I'm telling why. I don't know, some error is coming every time. R was not square, finding R from data. It's a core test dot Bartlett and then data one. Okay, it is warning only. So let us see what is in BART, chi-square and p-value. Yeah, so our ultimate aim, so it was only warning. So warning we can actually just ignore. You can just check in BART what is there. So you have to run from here also. You can just cover it, or you can just copy and paste in the second line and just see the value, right? So in the value, this is the chi-square test. So the value of chi-square is 440.6177. You know how to calculate the chi-square, right? And p-value is 8.13 e to the power minus 27. That means it's a very, very, very less than 0.05. That means our Bartlett test is also significant, right? And our null is rejected. That means the alternative is accepted. There is no correlation, right? So this test is also fine. It is also passed. Now you can also test one more test is there, that is called, so these three tests you can actually, if you are verifying these all tests, then your actually data analysis is more and more robust. You can just say our data is very good. So BART, now you can just check here, that is called determinant test. Determinant test. So in the determinant test, if the value of the determinant is positive, so determinant test. So if this test value, so we just write that, right? For the determinant test, you have to write det, and then you have to write core data, correlation data. You have to just matrix form you have to actually assign over here. So core data 1. And you have to see what is the value of the determinant test. You can see it is positive, right? So if the value of the determinant test is positive, that means your data is adequate in nature. So our data has passed all the levels, right? In all the levels, all the 3 tests, our data is actually fit. Now I have one question. Have you heard about the autocorrelation also? Anybody from the group? Autocorrelation? Yes. I think somebody is speaking, but I'm not able to hear. So have you heard about the autocorrelation or not? Is it required to test autocorrelation as well? And first of all, what is autocorrelation?
बताओ उसको रिस्पॉन्स दो हमें नहीं आता
correlation between variables.
Yes, Anjum. Anjum is telling something. Yeah. Okay, so what is autocorrelation and where it is required? So actually we have 2 category of the data, right? The first category is, the first category is called cross-sectional data, and the second category is called time series data, right? So what is time series data? Means the data which is dependent upon the time. So like forecasting data, right? Maybe if you can just think stock market data. Stock market data is how this is time series data, because every day you are actually taking that data. Every day you are actually collecting that data, right? So maybe date wise data you have. Okay. So how it is dependent? So maybe today's stock is up, right? So it is likely that tomorrow's stock would be also up. So maybe some event has been there. Due to that event, maybe some election or maybe something has happened, and due to that our stock market is up, right? So it is likely tomorrow would also be up, right? So what is the cross correlation? Cross correlation is if your data is correlated with the other day data, right? Maybe today is up and tomorrow is also up. It is a kind of the correlation, right? So if such kind of the time series data is there, where correlation is there among the records, then we say there is a auto correlation, right? So auto correlation, why it is important? Because in time series data, sometimes we require auto correlation. With the auto correlation, you can actually predict the future as well. So maybe present value we have and lagged value. Lagged value means past value we have. If present and lagged value is actually same in nature, or maybe some correlation is there, so you can say there is a auto correlation, and it is likely that other day would also be kind of the same nature of the data would be there, right? So you can use auto correlation over here to predict the next value as well. But in cross sectional data, which we do over here as well, In the cross-sectional data, there is no requirement of the autocorrelation. Why? So I'm just giving one example. So what is the cross-correlation data? Suppose credit scoring data is there. So credit, suppose you have a bank, right? And in the bank, you have actually just launched that credit scoring model over there, right? With some machine learning. And so what is the beauty of that credit scoring? So you can predict with some that credit scoring whether the person is defaulter or not. So why this kind of analysis is important? Because some new person would be coming, and then you can decide whether you have to allow the credit to that person or not, credit card to that person or not. So that's why this credit scoring is important. So here we have to take past credit holder data. So each and every data, past data, is actually independent from each other. There is no time series here. So my data is actually different from the Chandan data and is different from the Sina data, right? So everybody have their different data of the credit scoring, past credit. So that's why here we assume there should not be autocorrelation. So that's why autocorrelation value should be avoided. So at the last, I will tell you how to calculate the uh, autocorrelation value as well. Now factor analysis, I'm just again coming to the factor analysis. Now, how many factors are there here? I don't know actually, right? I don't know how many factors would be there. So for that, we do parallel analysis. So what is parallel analysis? In the parallel analysis, we actually do some plot, right? So I'm just writing here. So parallel analysis underscore analysis. Just a minute. Yes, parallel analysis, how to do? So for that we use FA dot parallel, and then you have to provide the data. Okay, and I'm telling you what is the parallel analysis. 1 minute. So here, if you can see, after running the parallel analysis, what is there? Parallel analysis suggests that there are number of the factors 6 and the number of the component is 6. So what is the parallel analysis? Actually, it is done with the, so if you can see, when you just run this analysis, you will be getting this data. Here, this y-axis is eigenvalues and this x-axis is factors, right? So you have to just see eigenvalue 1. If your factors, if your principal component have eigenvalue 1 or greater than 1, you have to suggest that many factor would be there. So how many factor would be there? If you can just see from here, for this data, this is called actual data. In the actual data, you are determining greater than 1 is 1, 2, and 3, right? 3 factors are there. And with PC principal component actual data, this is the principal component analysis actual data. So how many factors are there? 1, 2, 3, 4, 5, and 6, right? So how many factors you would be having? Actually, you would be having your factors in between 3 to 6, right? 6 would be the maximum number of the factors. So if you can see in the analysis as well, it is giving 6 number of the factors should be there. So that is how you can actually decide how many Factors would be there. So I'm sure till here there is no problem. Now we will do factor analysis, which is our ultimate goal, right? So and now we also know how many factors are there. So here I am going to do factor analysis. I'm giving FA as object name, right? So for the factor analysis, what is the factor analysis? We use FA, the function. Then you have to provide the data. Data 1, sorry. Then you have to give factor number. So n factors. N factors. So how many factors you have to give? Between 3 to 6, right? So I am starting from 5. Let us say 5 factors are there. And how we will decide, I will tell you. And then you have to give for factor rotation, because if you are not rotating the factor, so sometime all the factors would be loaded on a single factor. So factor rotation is equal to rotate is